Okay. All right. So for today, we will continue the chapter 3. Uh, okay, you can scan the QR code first. I think there's someone just come in. And I've repeated so many times since last Tuesday that you need to use the GApps account to join now. And by the way, for the homework, the answer key I just uploaded to the Google Classroom. I will make the reminder on the Moodle, and I think I've checked Moodle. Yeah, now Moodle is the server is down, so yeah, that's why we need the Google Classroom to back up all the information. So I don't think Moodle will be the only good option here because the server is down. You can check if you can access the Moodle, but because I cannot join the Moodle. I cannot log in through the Moodle. I think the server is down. So yeah, while you are, I'm not sure how many of you still not joining the Google Classroom. So I hope you guys can join the Google Classroom, okay? Because sometimes this is happening. The Moodle um, uh, is not really helpful sometimes. So Moodle server is down. And again, let me remind you for use GApps account for Google Meet. So you need to join Google Classroom. Okay, so let's do some review for a while. So what we have done. Uh, so last Tuesday, the questions for feedback. Let me just remind you. Uh, there are functions from A, B, C, D, and then there are also derivative of that functions from 1, 2, 3, 4, and then you need to match this all the possibility, which one is the function, which one is its derivative. But for the the quiz itself, I do need to apologize because I forgot to check the time. It's not updated to the newest one. It's still 15 seconds. It should be around 40 to 50. So how to make or how to match this function with the derivative? Okay, so first look at how the functions uh, in in the graph. Okay, when the function is increasing, when the function has stationary point or the minimum or maximum point, we see the number A. Okay, we see number A. Maybe I'm using maybe orange. Okay, we see the derivative, the tangent line is changing around here, and eventually at this point, it becomes horizontal tangent, right? So whenever you have horizontal tangent, So let's say that at this point here, the gradient is 0, or the tangent is 0. Okay. And also you can see this similarly here, also 0 here. So m is 0. Also here, here, right, and here. Okay. So what we are going to do is, this is the first step, the easy step to check whether the functions and their derivatives are matched or not. Okay. So first look at that, and then look at the derivative. Because it's derivative, we know that this will be positive and negative. So meaning the positive should be about how the functions is in terms of the tangent should be like, for example, this part here in the middle, let me change here, it's going up, right? It should be a positive m. If you see this one, this a negative, right? So this will be positive, this will be negative. Okay, and by that way, we can have where we can predict what is our derivative on specific functions. Okay. Now we are looking at a here. M equals 0 at 2 points here, right? At this point. And let's see, is there any derivative that is match our conditions? And from here, the one that are crossing 0 exactly at 2 points on the left and right is only this one, right? Number 2. So A is 2. And from that just one answer, you can exactly get correct. Okay? If you want to look more, like for example, this one here, the derivative is a stationary. The m is constant, right? The one who are constant is 4. So B is 4. Okay. And the same thing happened with the other. Like for example, what else we have? Here, the gradient in the middle is 0. So we need to find the one who are crossing that 0. We have two options, 1 and 3, right? But we need to have looking at D. This is 0, 0, 0. So it's having 3.0. So 3.0 is here. 1, 2, 3. So this will be C, right? And this will be also, this should be D, this should be C. Okay. And that's how we find that this is the answer. Okay. I hope you get it. Okay. So the first thing you need to observe is the gradient 0. It's the very basic observations. Okay. And if the function is look alike, then you need to do more observations. Probably you need to check the negative m and then positive m, how it looks like. Okay, we can check also and make sure that and confirm that our answer is correct. Okay. Okay. Okay, next one. Okay, this is I've repeated sometimes last Tuesday. If f is continuous, then f is differentiable. The one example that easy to remember is the absolute x. Okay. If you have this function here, this is probably the easiest example that you can think. Okay, it's not really that. Maybe here. Okay. Okay, so probably here, the absolute x, it is continuous. Okay, like you make this line or maybe this line, but the problem is exactly at the tip point, here, we are not sure whether m is positive or m is negative. The tangent is positive or negative. The derivative is negative or positive. We are not sure, right? So that's why it's continuous, but it's not differentiable. So it doesn't mean that if, if every function continues, then that function will be differentiable. That is wrong. But the differentiable, okay, differentiable. So if f differentiable, so if you can derive f, like for example, you can derive f to be f prime, then f is continuous. This is true. Okay, and you can also prove this through, you can check the limit from the left is equal with limit from the right, and it is equal with the function at that point. Okay? So it means that it's differentiable, then it's also continuous. Okay. Okay, you did a great job here. Okay. Yeah, congratulations once again. Okay. Okay. Okay, let's now continue to our chapter 3. I think, oh, wait a minute. Last time we already take our derivative through the product rule, I think. Let me check. Okay, let me check here. Yeah, a power rule. I haven't written any proof here, but I think uh, because I think the time is not really enough, I will add another video. Maybe this week I will upload. That will be additional informations for some proof theorem for the derivatives, and I think it is really really good if you want to know more or understand more about how to prove whether the theorem is true or not. And then we move on for some basic derivative rules, for some subtractions, and then the constant. If you have a constant, I think that's intuitively not really complicated. And then we have this product rule, and I've shown you some part of how to prove the product rule. And I think in your textbook, if you have the textbook, the product rule a little bit different way for showing the proof. I will show you maybe in also additional video how to prove from the on your textbook. So proof for the general power rule and then product rule and also quotient rule. I will put in another additional video. And now actually we will go to the quotient rule in my personal I prefer to show you like this one here. I think for me it's much more um, clear. I think the textbook is also good, but my just my preferable just my preference. Okay, so this is the product rule, and we prove that okay, this is true, that this is our formula for product rule. And yeah, we should go to the quotient rule, but before we go to quotient rule, I forgot to mention the exponential. So let's go to exponential first and then the quotient rule. Okay, hope you don't mind. Okay, that's sorry. Okay, okay, let's go to the exponential functions. Okay, so what you know about exponential functions? Okay, so I think I've showed you before. I forgot when, but I think I've showed you if you have, for example, the x squared, and you have 2 with the power of x. Okay. You need to know what's the difference between these two, okay. At least from the graph. Okay. Can we get the graph here? Let me check. wait a moment. Let me check the. Okay. I think we can go to Geogebra first, uh, just to show you the graph. Okay, let's consider. Okay, the graph in Geogebra here is the red color one is x squared, and the blue one is with 2 with the power of x. Of course, you will see that uh, okay, let me go through slowly. Okay, so at the beginning, at x equals 0, let's just observe from x equals 0. From x equals 0, of course, in exponential, 2 with the power of 0, it's 1. And then the x squared is still below the exponential, right? And then we move on to maybe going to 2.5, still it's changed. And also at x equal 2, it's going to cross here. And then x squared seems to win, right? Seems it at the top of the two of functions. But then look at this. Slowly, the exponential going really uh, fast, which means it's increasing in a rate that is faster than the x squared. If we check also, I think we can go back to. Okay, we can go back to here. Right. So if you look at the function, so this is the exponential, and if you remember, we are having this. It should be, it should be crossing here, and it's going faster. Okay, yeah, it's not really good my drawing, but I hope you get the idea. So at the conclusions, this 2 with the power of x, this the exponent, uh, it's going faster, uh, increase faster than x squared. Okay, and let me check. Okay, now let's say we have any exponential functions. Uh, maybe b, maybe it's for the base. Okay, if you remember exponent and logarithm, so b is stand for base, so it can be any number. Okay, it can be 2, 3, 4, and etc. Okay, now let's check with our limit. Okay, okay, remember we have our definition. and then we can change all the f with the b with x. So this will be b and x plus h and minus b with the power of x. All right, and we can uh, simplify and maybe make it into bx and bh, right? Okay, and then we can also make bx, and then this will be bh minus 1 divided by 8, right? Okay, now we can make this bx, b with power of x, I mean, this one here. It doesn't depends on age, right? So I can actually factor b with power of x out. So we can have b to the power of x and then b h minus 1. Oh, sorry, to be a limit here. Okay, now we have this, right? And then to show you the idea behind this derivative here. Now the problem is we need to compute this, right? What's this value are? Okay. Now we can also check. Okay, we can also check. So let me write here, if b is equal to, okay. So I have limit as h closer to 0, and then we can write down this divided by h. And how we are going to have, right? Because this will be 0 over 0. We can have uh, several table or several numbers in a table. Okay, so we start from h is 0 0.1, 0 0.01, 0 0.001. We can try that, and then we can calculate the two, right? Or let me just write the results. Results will be 2h minus. This will be resulting 0.71773. This will be resulting 0.6955 something. This will result in 0.69339 something. And you can actually add more zero and then check the results. And you can also try another number. If you would like p is equal 3, you can also check. And you can also check the same way with 0 0.1, 0 0.001, and so on and so forth. What we'll get here is maybe I will make this and this maybe a little bit right. Okay. Now I can fill in this with the 3. So let's say we have 3. If you have 0 0.1, you will get 1.1612, blah, blah, blah. And you have 0 0.01, you have 1.1046 something. And if you have 0.001, you will get 10992 something. Okay. And you will see that it will get around 6 for 2 is 0.69 something, and for the 3, you will get 1.01 something. Okay, so in between this uh, 2 and 3, okay, in between 2 and 3 you will have 1, right, between this and this. So there will be b, okay, there will be b in between this, right? So b equal 2 point something, right, between 2 and 3. That makes the limit here equal 1. Okay. And that is actually e. Okay, so e is such number that when you plug into this definition here, it will be equal to 1. Okay, e is 2.7818. Oh, sorry, and it's going through a lot of decimals. Okay, and we call this irrational number. Like when you have pi, also irrational number, also square root of 2, also irrational number, and we have also e. Okay. Now we have e. Okay, so basically this number here, that's 0, 6, 9, and 109 is, this is ln 2, this is ln 3. Ln is our logarithm with the base e. So this is a uh, log e. Okay, log e. Ln is log e. So log e2 is ln2. Okay. Okay. We call logarithm our natural logarithm. Okay. Why we call natural logarithm? Because actually these decimals here that we know as e, we can find in any nature structure. Okay. Like in ratio, it's similar to the golden ratio. If you know the golden ratio, e is somewhat similar that you can find also in nature. And the most, I think the most obvious one is populations, because population increase exponentially. You can find this number e within the formula for populations. Okay, so is such important number. Okay. But now we are going to use this e into our calculus problem. Okay, so that is the definitions. All right. Okay, let me check. Uh, okay. Okay. So back here, when b is e, when b is e, then f prime x is e to the x. And this is really important because the functions and its derivative is actually the same. So when you are deriving the functions, it is still becoming the original. It doesn't going anywhere, right? Okay, if you look here, if you check uh, where e to the x will be, you can see that uh, 2 with power of x here and 3 power of x here. E is in between those numbers. Okay. And uh, at, let me write here, at 1, 0, right? We have y e to the x, y is e, right? We check x to the functions, right? And the tangent, okay, the tangent y prime is the same e to the x, right? Right? And it's also e at this point. So the tangent and the original is the same. So this is actually e. Okay. So that's I think interesting. Okay. And if you look at the slope at a point by point, how the slope will be. This is the slope is 1, and the slope e to the x. Okay, so when oh wait, this should be, oh yeah, wait, 0. Okay. Oh wait. It should be 1. What I'm going to tell you is not this area, but sorry, this area. So this is E. Okay. All right. Okay. So let me make some conclusion from here that, or maybe in the next slide, that when you have e to the x or e to the x is e to the x. So the uh, property of e to the x is it is its own derivative. Okay. Okay. Let me give you some example, and maybe a typical questions that may be in your uh, practice problem will be shown up. So, for example, if you want uh, to observe at what point on the curve y is equal e to the x is the tangent line parallel to the line y equal to x. So which means if I'm drawing the illustrations, maybe this is the e, and maybe e to the 2x is maybe here. Okay, maybe a little bit here. And we need to find anywhere in the curve that is having similar or parallel with the uh, y equal to x. Okay, So we need to find this and eventually find the point. Or maybe let me just write, need to find is this, find the point. Okay, that's what you need to do. So of course, if you remember, the tangent line is basically the derivative. So we can make the derivative of e is just the same e to the x, right? And let this become a and f of a. So we can write this is e to the a, right? Or we can write this slope is e to the a, or maybe if you write slope at a, f of a is e to the a is also fine. And then parallel to so it is m, the m a is parallel to m, let's say the line, let's say m2. Okay, just making the name. So e to the a is equal to, so a is, now you need to remember a little bit of logarithm. I hope you still remember logarithm. Okay, this is ln 2. Okay, so the point is sometimes when you have this kind of question and you write in the paper and you're getting late ln2, but actually the question is asking the point, so you need to answer completely. So point is ln2 and put in ln times 2. Okay, I hope you get the idea. So there's a lot of questions if you check your textbook, asking about the tangent line parallel, tangent line perpendicular. For example, uh, you have this, any curve, and you have a tangent like that. You know that this is having a gradient, right? Some number there. Uh, but we can also make the one that are perpendicular here. So this is when m1 is perpendicular with the other. Okay, and you know this should be, when you multiply this two, should be equal -1. If parallel, it should be equal. Okay, just to keep in mind, because there are a lot of problems that are asking the tangent line, maybe parallel, perpendicular, find on some point, finding the point itself, or maybe finding the tangent line. Okay, I think I will go back to this kind of questions later. If we probably finishing all the derivative tools you need, okay, the basic tools you need, and then some proof that I will give to you. So maybe it will be focusing on maybe next week for some practice. Okay. Okay. The E also, this is just FYI, okay, just for your information. The E also can be found in this kind of continuous fraction like this. and it can have many fractions. It is precisely the way that we know. Okay. Also, e can be described as 1 plus. This is, I think we will have this on calculus too, but I think we will go later on calculus too. Okay, and I think I need to also write what will happen if this is happen. This is actually equal with bx and ln(b). Okay, because we already have the definition from e, so we can write this is as ln(b). So this is these two for the exponential. All right. So now I will go back to the quotient rule that we will deliver. So product rule, finish exponential and go back to the quotient rule. Okay, any questions first? Any questions? Uh, okay, if not, then let's move to quotient rule. Okay, the quotient rule. Uh, Let me write similar with the product rule. So let's just using the big F to mention this. And then we can write the general terms for the derivative. Okay, this is the general term. And we can now do some calculations and simplifications. Okay. Now I will make this, I will merge this part. Okay. I will merge become, I think I'm writing too big, so let me move a little bit here and make it another sign here. So this will be h and then gx plus h. Okay, and we will have this part will be gx and then fx plus h, and then minus f of x and gx plus h. Now, similar idea with the product rule, we need to add and sub with fx gx. Uh, Add and subtract. Okay, subtract. So why we need to add and subtract with this? Because in terms of simplification, we may need some grouping for the limit that probably we can further simplify and becomes maybe derivative. Okay, let me write f first and then g, and then minus and plus, and then plus, oh sorry, minus, and this will be h g. Okay, now the next part will be grouping f of x and g of x. So let's start with g of x, and then we have um, fx plus a. I'm skipping some steps here, but I hope you still get my point here. I will move h to the top equation, so I will write h in both left and side right equation here. And the bottom equation will left with the gx plus h and gx. Okay. So I'm moving the h to the top equations. And now you will see that this part and this part, we can write them as our derivative, right? So we can have this limit h0, this also limit as h0, and then we can write the definition becomes, this will be gx and then f prime x minus g f of x and then g prime x, and divide by, this will be g x and then square. This is f prime. But to help you remember, I will always, because remember that the product rule, I'm writing the product rule as f f prime x and gx, and then plus g prime x f of x. It's the same thing at the top equation of the quotient rule, right? So it's better. So let me write here. This is product rule. It is better to keep f g f like this, and then, because the problem is on the quotient rule, it has minus. This minus sometimes make the calculation seems difficult, because if it's plus, it doesn't really necessary to have like precisely FGGF. You can have which one first, because eventually you will add both of those elements, right? But here, what I want to suggest to you is just write this similarly, so you have a similar form, but the difference is, in product rule it's plus, in the quotient rule it's minus, and you need to divide with g of x squared. Okay, that's the difference. Okay, so this will be quotient rule. Okay. Okay. Now let's go to uh, maybe giving you some example before we move on to the trigonometric functions, because I hope I can make it today for trigonometric. But let's try some example first before we go there. Okay, example, uh, find the equation of tangent line and normal line to the curve okay, maybe giving you a few minutes to check and maybe practicing your skills in derivative. I know most of you already get the product rule and quotient rule from high school, so maybe you can have some practice remembering how to derive. Okay, because usually, uh, in my experience, high school students they can derive functions, derive the formula easily, but sometimes they mix up the concept. Sometimes they not sure about how to prove or how to apply it in a certain um, uh, implementations. Okay? So yeah, but at least for skills, I, I do have confidence that you can do it. Okay, so you need just to review and practice for this is about the technique. Okay, different thing from observations. Okay, okay, try for a few minutes. Okay, let me step by step slowly giving you the idea behind the question. It's a similar question with the exponent one that I gave you before. It's asking the equation of tangent line. Okay, so again, a tangent, a derivative, same thing. It's the slope. Okay, we need to find the slope of the function, or this is the dy over dx, the derivative, right? So the first thing to do, we can take our function right down here, and then we can find the y prime or dy over dx, any notations you can write, right? And then write them here, and then remember the quotient rule. Okay, so let's start from the bottom. We have 1 plus x squared and then squared. Okay, and then we need to, let's say this is f, this is g, so we need to find f prime and g prime, and let's start finding the f prime. Okay, if you see any square root of x, it will be this, right? But if you're not sure how to find this, we can start with uh, x with power of half, and then we can start with the power rule, half going here, and then this is half minus one, right? It's minus half, so it's going down and making this. Okay, but I hope you can make it fast because it's frequently appear. Okay, so we can write this 1 over 2 square root of x, and then 1 plus x squared g, and then minus finding g prime, it's 2x, 2x, right? From here, g prime. And then write the f is square root of x. Okay, do we need to solve or do we need to simplify? I think not, right? Not necessarily. You can just look at the point here, 1.5. So we can write, or maybe dy over dx and write this, and then write 1.5. Meaning this notations means that you are going to evaluate the derivative on this point. Okay? And then we can evaluate this. Okay. So this will be 4. This will be half and 2, right? And minus 2, right? So this will be having negative 1 over 4. That is our gradient. So this gradient m is negative 1 over 4. Then the normal gradient, we can have 4. Right? Then the tangent line, we can use the line equations and solve and make it into, it's half, yeah, okay. And also normal line, we have normal line, same thing with different gradient. Okay, so this will be our tangent line and this will be our normal line. Okay, okay. um yeah, we can move on to the next sections about the um, trigonometric, and then we can have some review later on. Okay. Okay. And if you have some questions regarding maybe some homework that you need to elaborate more, I think in the answer key, most of the answers are very clear. Okay, and I hope all answer key very clear. And if you need more discussion about the answer key, let me know. You can send me an email or maybe just send me message through Moodle. But I think Moodle's still down for today, maybe tomorrow. Okay. So okay. Example. Okay. Okay. And any questions? Any questions? Anything? And remember, you need to prepare for some time uh, for a small quiz, and you can do it anywhere. Um, you can do it by maybe looking at your notes, your textbook. That's still okay, but I will limit the time. So yeah, I hope it is enough. Okay, if there's no questions, let me move to derivative of trigonometric functions. All right, we can have, for example, for trigonometric, we will start with the sine x. Okay, and I hope you still remember how to make the graph for the sine and then cosine x and then tangent x. Okay, and remember that every trigonometric function is continuous on its domain. On its domain. Okay, like for example, the tangent. You know that the tangent has infinite, right? Infinite point. So at tangent pi over 2, it will be going to be infinite, right? And that's why when you have the ln and then uh, or maybe the tangent inverse means uh, it's actually asking the the uh, the angle, right? The question is this, right? 1 over x, and then its limit as x going to 0 from the right. Step by step, if you are looking at this, the idea is to probably making the t is 1 over x, or any variable you want to make. Okay. But I make t as our variable now. So as x going to uh, positive infinity, t will be also going to infinity, right? So we can have limit as t going to infinite, right? And then this will be tangent inverse t. Okay, and I think this will be very clear that this is actually equal with pi over 2. Okay, why the answer is just pi over 2? Because by default, okay, by default, you remember the tangent inverse, we already restrict the domain. Okay, so that's why it continues on its domain. Okay, that's what it means. And also, if you remember the other question similar, I think this one, ln sine x as the limit from x going to pi, but from the left. Okay, similar with the with what we have done in tangent inverse here, we can also make the t as sine x, and then we can make as x is going to pi from the left. What will happen with sine? It's going to be 0 from the right. You can check with the graph if you would like. If you draw the graph, so this is pi over 2. This is pi, right? So what will happen is going here is going to reach 0, right? So we can write this limit as t approaching 0 positive of ln t, and that's why we have negative infinity. Okay. Okay. Maybe confirmation one more time. Okay. How to write, like maybe you have infinite, negative infinite, and you have doesn't exist. Okay. Basically, okay. Basically, this part, this is also doesn't exist because there is no certain value. But because you already learned about the infinite limit, okay, infinite limit, and also limits at infinity, we may have some number that are really large, then we know that we can have that as positive infinity or negative infinity. So sometimes we need to write completely Okay, we can write this is doesn't exist, but you need to make some additional information that uh, uh, the result or the limit is arbitrarily large, or if this is difficult to write, maybe limit is larger and unbounded. Uh, so we can stop at some point, right? So that's how you need to write. Okay, it's not enough if you just write it doesn't exist. You need to make sure that how doesn't exist is the limit. Okay, is it because maybe limit is not the same as the right limit? This pretty much doesn't exist. For example, uh, this also correct. Uh, it's going down, and then from here it's going up. But if we are going to just look at the number, we can say that this is going to negative infinity, this is infinity. But the existence of limit is we can precisely write the left hand and right hand limit. And because it's not equal, it doesn't exist. Okay. But if you want to look at just one side of limit, we can say it's going to have negatively large, or it's going to have a really, really large result. Okay. I hope you get my point from the last Tuesday class. Okay. All right. Now, from the graph of sine x, if we look at how the tangent will be, okay, the tangent will be, we can consider from this sides. Okay, this will be 0, the horizontal tangent, and this will be negative, right? It's going down, okay, and it's back to the negative, back to the 0, and then positive, and then 0 again, and then negative, and then 0 again, right? And then it's going to have a cycle. Okay, so if we are going to look the what's the derivative, see from here is 0. So when it's 0 at this point here, then it should be 0 here, right? Okay, and when it's going to have a negative here, okay, you see that from here it's negative, right? It's negative. You look at here, it's all in negative area, right? So this negative, this positive. So the whole thing here is negative. Okay. Sometimes what students thinking is they sometimes difficult to differentiate between the functions and the derivative, because when they look at here, they are thinking that this is gradient, and oh, it's going down, it's going up, it's negative, it's positive. They forget that this is actually already been derived. Okay, it's already been derived. So you need to look at the value itself. The value itself is negative, this negative, right? And here is positive, the one uh, in the top of 0, right? And again, you look here, it's equal 0, so it should be crossing 0 here, precisely that. And you get the positive here, so this all positive. So it's the same thing, it's positive here, right? And you can see the rest of the cycle repeat and repeat and repeat. It's the same uh, cycles for sine. And from there, we can have some conclusions, or maybe before we go to conclusions, we can make some proof with the um, definition for derivative. Okay, and then we can use sine x. So we can start with writing down the derivative by limit definition. And then we can try to simplify and try to solve this with limit. Okay, so it will be sine x plus h and then minus sine x. And then we get use some formula in trigonometric, sine x plus h, so you have sine x cos h. I hope you still remember. Okay, plus cos x sine h. Okay, and minus sine x, and divide by h. Okay, now we can grouping. Okay, let's say the grouping. We have sine x here and sine x here. So let's move that and group that. Uh, Let me write sine x and then cos h minus 1. Let's say we make it is as one grouping here. And then the second grouping is, let me write this as cos x sine h divided by h. And then if you still remember, we can write this one by one. So this is sine x and then limit and write down here and plus and limit. Okay, now how to solve this? I hope you still remember. I hope you still remember. I'm at the early limit. We already discovered that limit as x going to 0 sine x over x is equal 1 with squeeze theorem and so on, right? And then we make it here. It's 1, okay, based on our definitions. So that's why I explained at the beginning. If you look at this limit here and you know that you can, maybe you're thinking of L'Hopital rule, it's wrong in terms of uh, rules in math, because that is actually this form is the definition. So this is the definitions, right? So the definition. So here we get 1. This is also cos x. And here we already also, I think we have tried to solve it. If you don't remember, let me solve it to you. So limit x going to 0, cos x minus 1 divided by x. And then we start with rationalizing with the cos x plus 1 and cos x plus 1. And hopefully we can get some squared and then we can simplify. And this will be uh, minus, we can write this, right? Right? So this will be minus sine x minus, I'm forgetting the limit, sorry. So this will be minus sine squared x and then x cos x plus 1, and then it will be having this will be 1, or it's negative 1, right? So here is 0, so it will be 0. Okay. So this part is getting 0, so all this getting 0, and you will get the results will be plus x. Okay. All right. Let's see the conclusion here. So d dx sine x is equal cosine x. Okay. And same way, we can also make d dx cos x and then negative sine x. These two are important. And also we can have d dx tangent. If you forget, we can take some time to check our result. So we can have this sine divided by cos, and then we can have uh, fg, right? We can have this quotient rule. Okay? We can have quotient rule, so we can start to write the quotient rule. So this will be cos squared x. Okay, we start with the f prime, so it will be cos x minus g prime will be negative uh, sine x and sine x. So it will be cos squared x plus sine squared x, and this will be cos squared x, and we will have 1 over cos squared x. It will be equal to secant squared x. So d dx tangent is secant squared x. I think just this three trigonometric is, um, I believe, essentials. Okay, essentials for you. Um, but if you would like to add more, I think secant also is important. Secant x, tangent x. But the cosecant and the cotangent is, I think, not really necessary. So this is not really necessary here. These two. So you get 1, 2, 3, 4. So at least 4 trigonometric here. Um, you can at least get the idea. Okay. Let me check some example for you. Okay, first is, okay. Any question? If not, then okay. Let me give you some also idea. Uh, Find 27 derivative of cosine x. So usually you have like f prime, right? F double prime, and this is f27. The question is asking, and eventually, uh, you can also make it like maybe f30, f40, or maybe 100, 200. But first, what I want to share with you is the logic behind how we are going to find this. Okay, now first, let me show you what we are going to find when we have the f prime of the functions. So f prime is negative sine x, right? Okay, and if we derive second time, we get negative cosine x, right? We do the third time, we go for, it's going to have negative negative, so it should be positive sign. And we go for the fourth time, we get cosine x, right? Okay, the idea behind this many derivative, because sine or cosine, they will have some similar value when you derive, and it will be a cycling, right? It will be a cycle. So we derive one, right? We derive second, we derive third time, and we derive fourth time. So at fourth cycle, it's going back to the original equations. Okay. So let me write here. Whenever uh, let's say f with the power of with the derivative power of n of x. Okay, so whenever n is a multiple of 4, it's equal cos x whenever n is multiple of 4. Okay, so multiple 4 nearby the 27, so 27, we need to have 27, right? So the multiple 4 maybe 24, right? Or maybe 20. Okay, but I think the nearest one is 24. So we can say f24 is cos x. And then if you differentiate 3 more times, 1, 2, 3, it will be sine x, right? And then we get the answer. Okay. And probably you can have this kind of example of or questions similar with similar explanation, but maybe more complicated functions. But it has similar idea, and you need to find, maybe you need to find the pattern first, and then you get the idea. Oh, you can find the pattern, you can find the cycle, and then you can get easily finding the 27 derivative of the functions. Okay, any questions? All right. We still have some time left. Maybe I'm giving you another questions because you already know the about the sign definition by limit. If we have a limit as x approach 0 of sine 7x divided by 4x, Can you try to solve? The shortcut is the shortcut is 7/4. But you need to know how to going for the answer. Okay. Okay. Okay, we can start with, let's just put um 7/4 outside like that. And then this will be sine 7x and then 7x. It's the same thing, right? It's the same thing. Okay. And then from here, we can write 7/4 here. And then we can have this. All right. And then we can have, if you're still confused about the 7x, we can make the 7x as t. Okay. So as x going to 0, t also going to 0, right? So this is, we can write that this is limit as t going to 0 of sine t over t, which is equal 1. So we have this is 7/4. Okay. Okay, let me give you just a slight brief intro of the next section. Okay, so you already have some basic derivative introductions, and then you have the product rule, quotient rule. You have the exponential functions, e to the x, and you have trigonometric functions, sine, cosine, tangent. The next part is about, so I will going a little bit deeper, some tools for you, so we have like more tools, and then I will review at the end, like maybe in next week or next 2 weeks, so you have more idea. So I give you the tools first, and then maybe you have some session with your TA, you have some exercise, and maybe he will give you some homework, and maybe I will give you some homework too, maybe next week, to provide you for derivative. Okay. So let's move to the next session. Um, it's actually the chain rule. Okay, the chain rule. Okay, so first let me write some functions here. So the formula that we have, um, product rule, quotient rule, and so on and so forth. Can we try apply those formula directly to solve this derivative here? I don't think it will going to have direct results. Right? We need something to 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 solve this. Okay, and that is because the f it's actually is composite. What is composite? If you remember composite, the terms is f of g, right? This O is not O in the letter, it's like a circle. If you write in the code, Usually in LaTeX, if you know, it's you need to write circ. Anyone asking? Yeah, function inside the functions. Yeah, if you write in a LaTeX, you know that part of mathematical programming, you write circ, and then it will appear like that. Okay. Yeah, sometimes I forgot, so I googled how to write in LaTeX, and then oh yeah, you need to write circ or GOF or FOF like that. So this means F, and then G is inside F. So a function's inside the function, correct? So Rion, that is pretty much the idea. Okay? Function inside the function. Okay? And if we look the F here, it's going to have two functions, at least two functions that we can have the square root of x, and then G is x squared plus 1. And precisely this f of G become x squared plus 1 inside the square root of x. So it's become this, right? Okay. And we know how to find the this little f here. We can find the f prime, we can find the g prime. So we can also find the whole functions, the whole big F functions, right? Okay, let me give you the results here. So if f, the big F is f, and the g inside f, then if you have derivative, this will be f prime gx multiplied with g prime x. Okay, so let me write some notes here. So if g is differentiable at x and f is differentiable at g of x, then f is differentiable at x, and the f prime is equal to that. Okay, I think I can also make this into the additional video later for maybe some proof, just a little proofing. Okay. Okay, I think that's it for today. I think we don't have really much time left. Any questions? No? If not, then we, like usual, we will have some feedback time. Let me give you the QR code. Wait, let me just directly connect it to my Mentimeter. I hope the time is okay. I think I've set the time in a reasonable way, not like last Tuesday. Okay, so yeah, can join in, and actually, why I need to make this kind of interaction using this the QR code here. This is because I want to know whether you are understand the concept. Although it's not to be like you are really understand or not, but I just want to know whether you are at least in the surface of the concept, you know how to. Okay, you know how to. Okay. That's the why I'm using this, because I don't think every course, like maybe you have other course that really have this kind of learning check. Okay, learning check. Like, okay, you learn this, and then okay, I got it, and then if not, then you need to go back to review, if you need, right? Not every professor is doing this, and I want to, I want to know like how much you can, okay, and of course, for any one of you are who are not really familiar with English instructor, this kind of test is actually helping. Like maybe you can help yourself to like, oh, do I understand the concept, or do I need to review? Do I need to check the exercise? Do I need to make this case? Blah blah blah. Right. So yeah, I think it will benefit both of us. Right. So me as instructor, I know like from you, and you also know from this kind of test that you need to work on more in some other problems. Okay. Okay. Uh, I will start. If you have like a pen and paper, you can prepare that. Okay. Let's start with. Okay. Let's start with the first one. Okay. You need to bring out your name, ID if you want. Can make any name. Oh yeah, next Tuesday we will go to physical class. But if you want to stay online, that's okay. I will still keep the link open so you can join the lecture also. Okay, let's start with. Okay, let's start. 3, 2, 1. I'm going to enter. Okay, you need to find A and B. I hope the time is okay. It's not really complicated functions, but you need to read carefully. You have a parabola, you have the equation, and you need to find the value of A and B in the parabola. Yeah, I hope that the time is okay. Every time is okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, time's up. Oh, yeah, careful, careful. Okay, careful, careful. You need to check again your answer. All right. Oh, okay. Bobby fastest. Okay. Let's take the next one. If you are ready, 3, 2, 1. You need to write the answer, just the number. Okay, if you find the number. Remember horizontal tangent. Correct. What is horizontal tangent? If there is like more than like a characters, you can have a space or not. I think I've already put alternative answer if you are answering a little bit different. Okay, I hope you get right. Okay, 12, 11. Okay, just make random answer. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, time's up. Okay. Oh, there's also y equal ln2. I will make a corrections. Okay. So y equal ln2 is correct. So I will make a correction for that one later. So probably the leaderboard can be changed. Right. Okay. Okay. Now we have three winners now, but it can be changed later. So okay, but congratulations for all of you who are joining our feedback time. So hopefully it is beneficial for you. And this will be the end of our lecture. Okay, sorry for the time. And hopefully you can get the idea. And don't forget to practice. Okay, uh, you still can practice the review from the limit, like the one that I gave you. You can check the other numbers, and maybe if you feel that is not really, maybe for you is not quite understand, you can ask me, okay, in email, because some of the students actually asking me through email, and I've answered some questions from you guys. Okay, so you can check with me, and maybe solve the problem, or maybe having difficulty with some concept, you can also check with me. Okay, that's all for today. And next Tuesday we are going to meet in the class, hopefully. So that's the end of our lecture. You can leave the meeting if you like. All the attendance. Okay, wait. Let me go back to. Okay, here. Okay, don't forget, if you still not joining the Google Classroom, please join the Google Classroom, because sometimes the server is really bad. Okay, thank you all. Thank you all. Okay, thank you all. Thank you all for coming. Okay, if anyone need the QR code, please scan the QR code if you need one. All right. Okay, bye. Bye, everyone.